How are you, my friends? This is lecture 16 of the pre-calculus course about graphing cosine functions. Just to remind you, please, you can review lecture 15, graphs of sine functions. Also, at the end of this lecture 16, you can find some old exams questions to practice on both lectures. Now let's graph first the basic cosine function from 0 to 2 pi. Okay, if we take some numbers here, 0, pi over 2 pi, 3 pi over 2, and 2 pi, you can use the unit circle here to find the cosine. Cosine is the x value. Here, the sine is the y value, as you know. So f of x is equal cosine x, 0 and 1. So this is 1 point on the graph. Pi over 2, the cosine of pi over 2 will be 0. And cosine of pi will be minus 1 here. Cosine of 3 pi over 2 will be 0. Cosine of 2 pi will be 1. So the graph will start from 1 and it will go until 2 pi. This we call it 1 period. As you can see, the graph decreases from 0 until pi and increases from pi to 2 pi. Now what we see here is the complete graph of the basic cosine function. We can see many periods are there. And we know the cosine function is an even function. Cosine of minus x is the same as cosine of x. And every function which is even is symmetric with respect to the y-axis. So we can see here half of the graph to the right of the y-axis and the other half is to the left of y-axis. And this one here, the colored with this one, this is 1 period of the cosine function. The domain is all real numbers, the same as the sine function, and the range closed interval from -1 to 1, also as the sine function. Now to find x-intercept, we let y equal 0, and we see the next slide. This is a little different from the sine. X-intercept, put y equals 0. So we say cosine is equal to 0. So we ask, 1, the cosine is equal to 0. What are the values of the x that will make cosine 0? So the answer here, x will be pi over 2 plus n pi. There are many values of x that will make the cosine 0. So we say pi over 2, 3 pi over 2. You can add n as integer. You can put n 1, 2, 3, 4, or 0, or -1, -2, -3, -4. Now to find x-intercept in general here, so what do? You take the argument equals pi over 2 plus n pi. Please, you have to remember this. Then solve for x and just write n as integer. So for the simple cosine here, the argument is x. For other functions, different arguments, we will see later some examples. Let's see here, example 5. So we are continuing lecture 15 now. Graph 2 periods of the following function, f of x 1 minus cosine of the x. Find the range. So we know cosine of the x, we know the graph. This is the graph here, the complete graph. There is a minus here, that means that's a reflection. See the dashed one? Start with the basic cosine. This is the cosine here. And then the minus will be the reflection in the x-axis. That's a minus cosine. See, cosine here is this one, the black. And then you shift up 1 unit after you make the reflection. See, the blue is 1 period, and then the red is another period. You can draw many periods. So the graph is shifted up 1 unit. Let's see the range. D minus absolute value of A, D plus absolute value of A. We will see this formula. So D now is 1. A by itself is the coefficient of the cosine. So it's -1. See, A by itself is -1. So I put absolute value of -1, absolute value of -1. D is 1. So the range will be from 0 to 2 for our function here. Now let's look at the general cosine function. As I mentioned in lecture 15 for the sine function, we have A cosine k bracket x minus b. Let's see the argument here. Either you can write the argument as k bracket x minus b or kx minus kb. These are the same values, which is the argument. We call it correct argument. Now, a is the coefficient of the cosine always, and k is the coefficient of the x. Now, be careful now. The amplitude is the absolute value of the a. The period in general is p, 2 pi divided by k. The x-intercept I mentioned before, let y equal 0. Put the argument equals pi over 2 plus n pi, find x, where n is integer. The phase shift, shifting on the right and left, you let the argument equal 0, then find x. Also, if you take here k outside in the bracket x minus b, you can see the phase shift b. If b is positive, it's to the right. And if b minus b, the phase shift is minus b, it will be to the left. So that will be x plus something. Now the range without vertical shifting will be minus absolute value of a, absolute value of a. If we have a vertical shifting d, suppose here we have plus 5 or plus d, that would be the general range formula for sine function and the cosine function only. I will say it again, d minus absolute value of a, d plus absolute value of a. Now, the method of graphing cosine is the same as the method of graphing sine. Find the amplitude first, and let's see, find the period. For sure, we have to find the period, and see where the period starts, where the period ends. So this starts at S, and it will end at E. So to find S, put the argument equals 0. To find E, put argument equals 2 pi, exactly like graphing sine. Then you divide the period into 4 equal parts. S, this is the beginning, S plus P over 4, S plus P over 2, P is the period, S plus 3P over 4, S plus P, which is the end of the first period. Then you can repeat the graph. Now let's look at this nice graph here. F of x is equal 4 cosine 2x plus pi. Let's find the amplitude, find the phase shift, find the equation of the x-intercepts, and graph also one period. So we have to do here 5 things. Okay, f of x is equal 4 cosine. Where do we start? Now you can take 2 out. See here? You can take 2 common factor inside the cosine, x plus pi over 2. Now you can find the phase shift here, if you like, or take the correct argument. All of this is the correct argument. You don't have to do that. So this is k now. See, k is 2. So the period 2 pi over k. So the period is pi for this function. Now the amplitude is 4. Always the amplitude is positive. Let's find S and E. The first period, put the argument is equal to 0. The correct argument, all of it, not x plus pi over 2. All of that. See, all the correct argument. So x will be minus pi over 2. The graph will start from here. You see, this is S. Take the argument equals 2 pi. So x will be pi over 2. So take pi here minus pi on the other side, divide by 2. So pi over, this is the end. And we know the graph of the cosine like this. It will start here like from 4 without shifting. Here there is a shifting. See on the left. See this one, the difference between this and this. This one you can see the shifting on the left. This one you cannot see that. So if you take 2 out, it will be x plus pi over 2. From here you see after x, the coefficient 1, you see the shifting on the left, pi over 2. Okay, now let's divide the period into 4 equal parts. It will be pi of minus pi over 2, minus pi over 4 here, 0, and then pi over 4, pi over 2. So that's one period here. Now the range, we know the formula. The period is pi. Now let's find x-intercept. X-intercept, put the argument. This is for cosine, remember. Argument equals pi over 2 plus n pi. So 2x plus pi is equal pi over 2 plus n pi. Take this pi on the other side here, becomes minus pi, then divide by 2. So x will be minus pi over 4 plus n pi over 2. So this is the equation of x-intercept. This is the same equation here. N is equal integer. So you can take n0, n1, n2, n3, n4, or minus 1, minus 2, minus 3, minus 4. You will find all the x-intercepts. Now the phase shift, as I said, let argument equal 0, or you can see it. So shifting, the phase shift is minus pi over 2. You can see it from this here after you take k common factor. Now let's see, very important, very nice question. Find the sum of all x-intercepts. Just to mention, in this question here, in the question, example number 6, we said find the equation of the x-intercepts. So from this, you can find all x-intercepts. Now, in example number 7, we need to find the sum of all x-intercepts, which means we have to find the equation of the x-intercepts, replace the values of the n. In this interval, see, there's a condition here between minus 2 pi over 3, 4 pi over 3. In this interval only, in the given condition, we have to find the x-intercepts. Then we will add them, the values. Maybe we can ask, find the number of x-intercept, like 3 x-intercept, or 4, or 5, or 2. So the important part here, 2 cosine half 6x minus pi. Let's find the correct argument before we start. So what is the correct argument here? So you have to multiply the half inside. It will be 3x minus pi over 2. So the correct argument will be 3x minus pi over 2. Now directly we go to x-intercept, let y is equal to 0. So put the argument equals pi over 2 plus n pi. That's the rule for the cosine. Now 3x minus pi over 2 is equal pi over 2 plus n pi. See from the formula here. Take this on the other side, becomes pi. So divide by 3, pi over 3 plus n pi over 3 is the equation of the x-intercept. See, that's the equation. This one will give us all the x-intercept. Now we have a condition here, see? Minus 2 pi over 3, it's given there. Minus 2 pi over 3, given there here. See, it's given here until 4 pi over 3 open. So what do? I create an inequality, as we did in lecture 15. Create an inequality and solve it. So I take capital X, big X, this is the big X, the equation here, between minus 2 pi over 3, 4 pi over 3, open. Sometimes we have closed. If it is closed, you put equal. Maybe one is closed, one is open. Maybe both are closed, maybe both are open. Be careful. Now we take, this is big X, that means the equation, the whole equation, pi over 3 plus n pi over 3, between minus 2 pi over 3 and 4 pi over 3. Let's find n. N will tell us how many x-intercept we have. So this is compound inequality. See, this is from the last slide here. This is algebra course, lecture 25. So n is integer. So what do? We subtract here, minus pi over 3 from each side. See, this will go, minus pi over 3 there, minus pi over 3 there. Then you have to add. So this is minus 3 pi over 3, and this is 3 pi over 3. Let's multiply by 3, everything which is positive here. So we get minus 3 pi less than n pi less than 3 pi. Divide by pi, so n would be between minus 3 and 3. So let's find all these numbers. These are integers now. Listen, n is integer. So the numbers are minus 2, n is minus 2, minus 1, 0, 1, and 2. So how many values for the n's? 5 values, which means 5 x-intercept. Now let's find them. Find the 5 x-intercept using this equation. See the equation we found, pi over 3 plus n pi over 3. Then we add them. So we replace these values of n's, minus 2, minus 1, 0, 1, 2 there. Nice colors. So this is the equation for the x-intercept in this interval. If you change the interval, the values of the x-intercept will change and the number of the x-intercepts will change. So I put n minus 2, n minus 1, n0, n1, n2 in this equation here. So I get minus pi over 3, 0, pi over 3, 2 pi over 3, and pi. If I add all these together, I get 5 pi over 3 is the sum of the 5 x-intercepts in this interval. Now, this one is also nice. We have a function a cosine bx. The period is 8, and f of 4 is equal to 3. Let's find f of 5. See, we have to find a and b for sure. You can try it if you like before you see the answer. So this is the function now, a cosine bx. The period is 8. Let's start with the period. See, we know the formula, p, the period, 2 pi over k. K in our question now is b. So I put here 2 pi over b equals 8. All right, so cross multiply, you can find b pi over 4. So that's small b there. Now the function becomes like this, a cosine pi over 4x, that's the function. Still we have to find a. Now in the question given f of 4 is equal to 3, see that? F of 4 here is equal to 3. So 4 is the x and 3 is the y. So we have 4, 3, we can replace the coordinates of this point in the equation. So I put 3 there in the y, a cosine pi over 4 times the 4, the x is the 4. So 3 a cosine pi is minus 1, so a will be minus 3. Now the function becomes minus 3 cosine pi over 4x. That's the function we need, sorry, f of 5. So I replace 5 in the x again in the function. So minus 3 cosine 5 pi over 4. Now you have to check the other lectures, how to find cosine 5 pi over 4. You have to find the reference angle. 5 pi over 4 will be in quadrant 3. That's so easy to do. And then the cosine will be negative. So minus square root of 2 over 2 times the minus 3. So it will be 3 square root of 2 over 2 is f of 5. Just to mention here, you cannot expect here what is f of 5. Maybe you will say this is f of 4 is equal to 3, f of 5 is equal to some numbers. You have to find a and b to get the answer. Now here is another nice question really. Given a function r plus t cosine pi wx, t less than 0 here, t is negative. The range of this function minus 1 to 5, and the period is 6. Let's find the value of r minus t divided by w. So you have to take the information there, the range, you have to use it. You have to use the period is equal to 6. And then from there, you can find r, you can find t, you can find w. After that, you put r minus t divided by w will be one number. Now let's start. Remember, there's a condition r negative. Let's use the definition for the amplitude. The amplitude by definition, if you check lecture 15, the maximum minus the minimum divided by 2 is equal absolute value of a. All right, a is the coefficient of the cosine or the coefficient of the sine. So the maximum here in the range, always when you say maximum, the maximum value in the range. So 5 minus 1 is the minimum, divide by 2 is equal absolute value of the t here, you see? But I said t negative, so the absolute value of the t will be minus t there. So when you simplify this, you get t is equal to minus 3. Now, the function becomes now r minus 3 cosine pi wx. Now let's use the formula for the range. D minus absolute value of a, d plus absolute value of a. So I put here d is the r minus absolute value of minus 3, which is the t, and the a itself. r plus absolute value of minus 3. The range is minus 1 to 5. So either you can take r minus 3 is equal to minus 1, or you take r plus 3 is equal to 5. In both cases, r will be 2. So now we have found t, we have found r. What's left is the w. And then on the next slide, this is t is minus 3, and r is 2. Let's find the period. The formula for the period p, 2 pi divided by k. That's the general formula. Now, what is k in our question? See, the k is the coefficient of the x. So it's pi w, all of that. See, this is k here. And the period is 6 given. So cancel the pi, 6, 2 over w is equal to 6. So w will be 1 over 3. So I write the function here if I need it. 2 minus 3 sine pi over 3x. So let's find now r minus t. R is 2 minus minus 3. So that's 5 divided by w1 over 3. It will be 15 is the answer. Now let's graph absolute value of the cosine x, a part. Find the range where the graph is increasing on minus pi to pi. Now we know the graph of the cosine. So this is the graph of the cosine. It will start from 1 here. That's 1 period until 0 to 2 pi. So this is the basic cosine. We know that. Now when we have absolute value on the whole function, so we have to move the part below the x-axis. See, this is negative here, you see? This one is negative. This one is negative. Negative means below the x-axis minus y, which means minus y. So let's move the part below the x to be above the x. Because when you put absolute value of minus 7, it becomes 7. Absolute value of minus 9, it becomes 9. Absolute value of minus 10 becomes 10. So the positive part, I leave it, and the negative part, I make it positive. You see from here to there, from pi over 2 to 3 pi over 2. So this is the graph now of the absolute value of the cosine. The range will be 0 to 1. Where the graph is increasing from minus pi to pi. See, this is here, minus pi to pi. Where is increasing? From minus pi over 2 until 0 on the x-axis here, increasing from pi over 2 to pi union. Over this interval. If you change the interval, the answer will change. So this is part A, this is part B, and this is part C. Now, I will leave some questions for you to practice. This is a really nice one. See, this is a sine. These questions, all the exam questions to practice, these are for lectures 15 and 16. So some of them for sine function, some of them for cosine function. And here we have to graph sine absolute value of x. See, it's different from absolute value of the cosine, because here absolute value on the whole function, and this is absolute value only on the x. Find the range where the graph is below the x-axis on this interval. Another one, we have the graph of the sine, and we call it a sine bx. Find 4ab divided by pi. This is a multiple choice. This is, we did similar to this. This is d plus a sine 10 pi mx. A is less than 0. The range minus 1 over 2, 19 over 2, and the period 2 over 45. Let's find m plus d plus a. So we have to find m plus d plus a. All right. Find the number of x-intercepts of this function, sine function, over the interval. The important thing here is to find the correct argument. Where the graph of the cosine is above the x between pi over 6, 7 pi over 6. So you have to graph that. Find the interval or intervals where the graph of the function is increasing. See, this is absolute value on the whole function. So you graph the function inside first. Between this interval, that's the condition from minus 2 to 2. Now, this is a function cosine, 2 minus 5 cosine 2 pi x plus 4 pi. If the period is p and the phase shift is d, and the range is VW. Let's find the value of PDVW, multiply 4 values together. Now this is the graph of a cosine. I give you the equation, A cosine bracket nx plus d. So find A and D. Now here are the answers of the 8 questions related to sines and cosines. Please, for complete solution, you can see the video on graphs of sine and cosine functions, lectures 15 and 16 pre-calculus old exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is a pre-calculus course, lecture number 16. I wish I can see you in another video with another topic. Thank you very much for listening.